Okay, next up we have Amy Campbell. She works for ESA's Climate Office and is currently exploring the use of essential climate variables in forecasting environmental cholera risks in coastal India. She'll be talking about that shortly, and using space superpower on how to use space superpowers to enable change in water, energy, and transportation. Welcome, Amy.
So space can play a really critical role in monitoring our climate and how it's changing. And that's done mainly through something we call Earth observation. So we have satellites, and these are essentially our eyes in space. So looking down at the planet and giving us tons of information. So these satellites, they have sensors on board, and these can be very passive sensors, picking up the light and the energy that's leaving the Earth, or they can have more active sensors that send down some kind of signal, and that signal bounces off the Earth and returns to the satellite, and that holds lots of information. So the Climate Change Initiative, CCI, ESA's Climate Office is currently using this satellite data to make huge time series of data to quantify over 20 of what we call essential climate variables, like you can see here. So these range from biomass to sea surface temperature to snow. So components that quantify the Earth's climate. And these data sets can be generated using multiple satellites to create time series of the whole world on a monthly, weekly, or daily basis for up to 30 years at a time. And we really need long time series like this for climate science. And this really helps scientists understand trends in our climate and start getting that bigger picture from space to work out what might change in the future. And this holds a lot of potential compared to in situ data collection, so down on the ground, in terms of just the huge scale of data we can get from space. So I'm talking about global coverage, frequent data for years and years, reaching inaccessible areas like glaciers and the middle of the ocean. So things that generally are impractical or sometimes impossible to get from in situ techniques. Ultimately, when we're looking at the climate, we're talking about really complex global changes, and these need to be understood at a synoptic scale. And the perspective from space is what gives us that. And this might be a nice time to highlight some key bits of climate science. So Earth observation can provide the science to drive policy, which is really important. So if we look back a moment, there is evidence of Earth observation driving climate policy in the past. So the thinning of the ozone layer over the South Pole each spring, now known as the ozone hole, was actually discovered using Earth observation back in the mid-1980s, and continuous measurement from space provided the evidence needed for the Montreal Protocol, which was a global agreement to phase out ozone-depleting substances like CFCs, so chlorofluorocarbons, which were nasty things that used to be found in aerosols. Now, more recently, ESA's Sentinel-5P satellite has shown a record-breaking small ozone hole in 2019, so it looks like it's shrinking and recovering. Models predict that the Antarctic ozone layer will recover mostly by 2040. So we can see the positive, effective outcomes of the Montreal Protocol. Obviously, this isn't the end of the story. We need to continue to be monitored, but it's a good example to show how we can continue using Earth observation to push for climate action. And this shows what we're able to achieve by pulling together and monitoring using space. But bringing it back to the now, Earth observation is heavily involved in current